small video clip before I start talking too much.
No way. I'm getting hacked. No, this is major. They've already burned in the NCIS public firewall.
Not that much sound, but
I'm trying. It's moving too fast.
Just step up. Using our connection to the Infus database. Sever it.
I can't. It's a point attack. He or she is only going after my machine.
It's not possible. This DoD level 9 encryption would take months to get through. What is that, video game?
No, Tony, we're getting hacked.
The internet is computer, the entire NCIS network is next.
I can't stop him. Do something with E.
I've never seen code like this. Ah. Where'd it go?
I didn't do anything. I thought you did.
No. I didn't.
yeah. So, the reason I showed you this clip was to give you a glimpse into what programming and hacking and everything that has to do with computers is not about. The movie industry tends to, and the TV show industry tends to make these TV shows where they just throw programming terms after each other and two people stand side by side and do hacking. And that tends to sometimes give a wrong picture of what the actual life of a programmer or computer person is actually about. What you just saw there is just bullshit made up by a TV company. So a little bit of background. Who am I? Well, I already told you my name, but I'm a 26-year-old software engineer, entrepreneur. Been doing websites since I was maybe 15 years old, selling them to other local businesses that needed help creating websites. And since recently, maybe going on a bit of a year now, I've been an entrepreneur with an actual larger company that has multiple employees and founders. And I'm a bit of a professional degree collector. Never managed to find a job that I really liked. And I always thought that, hey, starting my own business would be the way to go for me, but I needed to find the right guys to find the business, so I just kept going to schools until I found the guys to start a company with, and finally managed to do that so I can finish my studies. Yeah. So, why are we here today? So, the basics of this event was to understand what code is. I don't know, how many of you have done any form of programming before? I know there's a few coders here. Okay, so there's a good amount of people here who have done coding. So this is going to be a bit boring for you guys, but hopefully we'll catch up and give you something interesting to discuss about in the end of the event. So it's going to be about like what code is, how to get started with programming, and most of all, how to work together with programmers. If you are a business person, marketing person, graphics person, who wants to get something done, how do you find the coders to do your project together and make something that you could sell or market as a company? The program for tonight is a basic one, and it's up there. I'm going to hold a small snack break in between there, and then you guys can run away if you want to. But let's start with what is code. Can anybody tell me what code is? No hands. Well, yeah.
A language.
A language. Okay, we got something. Well, code, is basically a way of you telling the computer that, hey, do stuff the way I'm telling you to do it. And what he said, code is a language. Some are more difficult than other. Difficulty, I mean, how much you have to understand of the computer's function in order to be able to write a program. I've divided them into 4 levels here, what I call the what the fuck level, where that's what the computer uses, which is basically zeros and ones. The assembler level, which is pretty much the same as the first one, but you can actually get stuff done there with a decent amount of documentation and a fair bit of perseverance. And then you go to the low-level programming, which is where you start to get away from this 0 and 1 stuff programming, and you get into this actual using of words. So you're actually using words that are very familiar to the English language to ask the computer to do something for you. And when you get to the higher level programming languages, you will have a large tool set of stuff available to you when writing these programs, which will make development of software much faster and easier. So to summarize, basically, the first one, impossible. The last one, what most people use to develop software today. And let's go through some of these languages. Programming languages are basically a multitude of ways to do the same thing. There are lots of languages out there. I don't even know half of them. But basically what it's a matter of is syntax. Every language, English, Swedish, Finnish, has its own syntax. You have a certain way of asking questions, and if you mix the language and the syntax up, the other person doesn't understand you. It's the same way with a computer. If you don't write the right syntax and the right code, the computer don't understand what to do with your commands. So basically, there are these high-level languages that I talked about in the previous slides, where we have these languages that provide you with a pretty English-oriented environment, where you have like the commands you write to the computer are very much like a spoken language, with some exceptions. But anyways, you can read that code without reading a manual by the side. And then you have these low-level programming languages, which are very close to the actual binary code, the ones and the zeros, where you're giving very precise instructions to the processing unit in a computer, which is a processor, the little chip that you might have heard about in the center of the computer. That's the one that decides what blinks on the screen, what gets typed when you press a button on the keyboard, that stuff. So higher level programming languages are the ones that are easy to type with and what people use to write the programs that you guys use every day. Lower level programming languages are used to write very, very integrated stuff, sort of like remote controls that you use in everyday life that doesn't have any user interfaces and stuff. You might ask yourself why there are so many programming languages. Well, like I said, they're basically just a different way of saying the same thing. Why somebody decided that we should have more than one programming language is because of preference. Why is there more than one car in the world when you could just make one that's really good? It's basically a question of people wanting to have a way to express themselves more effectively, and for certain things, certain languages are not very good. For example, a low-level programming language such as C is not very good to develop a website. It's what you would call overkill, and you would end up doing something very complex to achieve something very simple. So that's like the main reason for having multitude of languages, is that people want to find easier ways, more effective ways of doing tasks that otherwise might be very complex. Now, I talked to you about the different levels of programming. Now you might be asking yourself, where do you program? I mean, how do you get the actual code written? How does this happen? And what you use is pretty much like a text editing program, referred to as an integrated programming environment. Oh, integrated development environment, supposed to be not programming environment. These development environments are pretty much like your traditional word processor, like Word, whatever there's lots of these out there. Like there's open source alternatives and stuff like that. Pretty much it's a way to enter text into the computer, and the computer then is able to, or like in this case the development environment is able to actually turn this text into the ones and zeros that I showed you in the previous slide there. So basically you can see it as a stepping stone going backwards. If you write a high-level language, it gets converted to the lower levels until it's binary. And because the chip in the computer can only understand binary code, which is basically ones and zeros. So when I write a program, I use human language, but the computer only understands ones and zeros. There are many different development environments available. For example, if you're a Windows guy, you would be using probably Visual Studio. And if you're an Apple guy, you would be using Xcode. And if you're an open source guy, you would be using Eclipse or something similar to that. The only difference between these, again, like the multitude of programming languages, is preference. Most of them support many, many languages. And it's basically just your what you think is best for your needs. And once you've gotten the hold of like a programming language, and you say like, hey, I want to write a program, I want to make something that does something with my computer. Typically, this would be a website for most people. Statistically, this is the most easy way to get started with programming, is to have a website project that you get going with. That's how it started for me way back then when I was like 10, 11. I wanted to make my own website, so that's how I got going with that. And I just took out the computer and I started up some text editor and I started writing web page code using a book that I bought from a local bookstore. So the computer does something that you want to do, and most of the programming examples, if you go and get a book, the first program you're going to write is the Hello World program. This is basically, you get the computer to print out the words Hello World on the screen, and bam, you just written your first program and the computer did something you asked it to do. For many people, this is like the aha moment where you realize, hey, this is quite cool. I can make it write all the stuff. I don't have to make it just write Hello World. I can make it write whatever. I can make a calculator or whatever. Once you get the basics of what you can do with a computer and you get it to print stuff on the screen, that's usually when the interest starts growing and you see that, hey, I can do this stuff really basically, but then when you start reading on, you realize how much you can actually do with a programming language. In this example here, I'm using a programming language called PHP, and it's basically this syntax that you see here is all you need to print Hello World in a web browser. Yeah, that's pretty much the first exposure most people have to programming. And that's if you open up a book that's telling people how to start programming, that's probably going to be on the first 10 pages. So another thing, what is a programmer? Well, we've talked about code, and it's something that I run into a lot of times is like people think that if you want to code, you have to be some sort of like uber person that can understand everything like that, and a mathematical genius that can like do difficult formulas in their sleep and stuff. That's not the case. Most people can become programmers with a good amount of dedication. Fellow co-worker of mine pointed out today that there was some recent study done that certain people are unable to be taught programming. I guess that's true. I mean, there's lots of people that can't do stuff. I mean, it's probably have to do something with your interest. But in the end, I think it's mostly up to you and the amount of dedication you're willing to put into learning something. There's an old saying that says that you have to do something for 10,000 hours before you're really good at it. I think the same applies to programming. If you want to learn how to program, you have to do it for 10,000 hours before you're really good at it. Now, 10,000 hours sounds like a lot of time, but if you get a job as a developer or study programming in a university or some other school, then it's really not that much when you start dividing it up. And in the end, what you will end up with is programming skills. I mean, you have to really try hard to not learn something during 10,000 hours. Yeah, and there's different kind of programmers. I mean, as there are different languages, there are different platforms, there's different ways of doing stuff. So I've tried to divide them up here into the types that I can easily identify, at least from like working with code and coders. The first is the web developer. He's a typically very, very visual guy. He would like drawing concepts and then start like doing the code, like really like thinking visually. And then there's the app developer, which is sort of a old new kind of developer. I mean, apps have been around for years, but it's only been since the iPhone that people have actually started mentioning apps and talking about, oh, do you have this app? And thus the mobile developers are really like starting to pop up now, and because of the touch screens that are available on phones now, that's like really huge because you can do a lot more now than what you could with old Nokias and old Windows mobile phones. Then there's the C guru. This is the guy who's typically quite shy, bearded, and the most difficult to approach in a conversation. But this guy will probably be the most talented programmer in your team when it comes to understanding a system on the root level. And that is like the actual system level the system works on and what you can do in practicality with any computer. And these are hard to come by. These are far and few between, and few and far between, I'm sorry. And they're also like not that well taught in universities anymore. This is the guy that's dedicated his life to learning something and being good at it. The fourth one is the architect. That's someone who likes designing systems. These are also hard to come by. People who love to make diagrams and make stuff into compartments, and this is how we're going to code this program, and this is the way that is the most effective way to do it. I.e., you can think of this guy as a normal guy building a big house. If you don't get the drawings right, the building's not going to be right in the end. And that's why this guy is really, really important. And the last guy is the MacGyver coder. He's the guy who pretty much can listen to a concept, be it a background server service, a web page, a app, and just get something done that works and that you can show to people. Typically, this kind of coder or like coding style means that you have to rebuild it at some point and make it actually work. But this is good for prototyping, and having a MacGyver coder in your team usually means that you can get stuff tested pretty fast and you don't have to ask 15 different people to do something that one guy can do most of. So like, yeah, these are my interpretations of the different coders that are out there. I don't know if it's correct, but this is my view of things. Now, I put this slide here because I wanted, like, people came here tonight, so I'm assuming that you have some sort of interest and no gun threats were involved. Are you a programmer? I mean, if you want to learn how to do programming, do a website, do anything like this, then there's a certain interest that you have to have. You have to be like one of those people that like to make things work, like to make lights blink on a website. You've also wondered, how could I make this on my own website? You've seen something and then like think, I would like to make my blog look like that. I would like to do something. Then that's the start. That's where it all needs to start. You become a programmer when you mastered how to do something. It's not something you can say that I wrote the Hello World program, I better print out my programmer certificate. It's more like a thing that you become once you've done enough of the stuff. And yeah, so if you're all programmers in my eyes, and like when you started doing something that makes the computer do stuff for you. And the last bit about programming here is the fact that the job market is quite interesting for programmers. I mean, we're all talking now about the recession and stuff, and people are losing jobs. And the funny thing is that we keep getting, I wouldn't say on a weekly basis, but on a monthly basis, there's job offers coming in. People asking me, my friends, do we know anybody who could come to this company, help them out? They need this many coders, they need that many coders for this project. And so this whole recession thing hasn't really been that visible to coders yet. If you're a good coder, then you will have a job in Finland at least. And from what I read in San Francisco and the States, they have the same problem that they can't find coders. for the projects, which means that they actually have to fly people from Europe to work there just because there's no way of getting them to the teams. So the backend gurus, again, like the C guy I was telling you about, those are the people that build your systems. Like say you want to build a Facebook killer, you're going to need a guy who can write really good software for you. And those guys don't fall off trees. I mean, they rarely want to exit like a secure job like at Nokia or somewhere else. A programmer basically wants to find something he likes. If he gets a good pay, why would he want to come and work in your startup for breadcrumbs when he could be making tens of thousands of euros at Nokia or Ericsson or any of the other like big telecom companies or software companies that are out there? So finding a coder these days is really difficult because there's such a high demand and other people are offering really good paychecks. And the third thing here is that you have to be really interested in what you do. I mean, there's many people who graduate from software engineering programs and don't get a job because they've completed a software engineering program and they have the degree, but if they're not like passionate about what they do, then they're not going to get a job as a programmer because most programming interviews are basically tasks you have to perform in front of a guy who's interviewing you. So if you don't know how to program, then they won't hire you. And yeah, the last one is basically what I said, that good programmers can afford to be picky because there's enough jobs out there. Now, onward. The web, mobile, and embedded part is something that I wanted to discuss because these are one of the three biggest components of consumer electronics, web, of course, and this is the stuff that we use every day. How do you develop a website? How do you develop a mobile phone app? How do you develop an embedded system? These are the stuff like that most startup teams start out with. Like if they are like driven towards this market, they need to find a way to develop this stuff. If you don't know the differences between a web service and an embedded system or a mobile app, and you're looking for a programmer, then you're screwed. Because you have to know how to identify the right criteria in the people you are looking for. You can't go looking for a coder, general coder that knows how to do something, but you're not sure if he's the right person for your project. You want to find a guy who's a web programmer, mobile programmer that has some experience. So knowing what you're looking for is as important as finding the right person, because otherwise it's going to be a big problem for you in the later parts of the development process. And websites, yeah. Most websites today are programmed using a hypertext markup language. The reason I put the bunny ears up there is that HTML isn't really a programming language. It's more of a markup language. The difference is that a markup language is quite basic. It's not really like you're telling the computer, you're not compiling any code that has to be run deep into the processor and stuff like that. It's more of an interpretive layout. I wish I had a whiteboard here now. I don't have one. I think it's in there, but yeah. And CSS, that's another big part of the web design. How many people here have heard of HTML5 and CSS, by the way? Yeah, so I would say 90%. Yeah, so these two, HTML5 and CSS, they are the most important parts of modern-day web development. If you're doing anything with web these days, this is the two you want to be learning about. Because with these two, you can build most modern websites today. JavaScript is what makes the stuff happen on your website. Say you have a website built on HTML5, you would use CSS or cascading style sheets to make the website look like something. You want to give it an appearance, you want to give the text color. That's the stuff that you do via CSS. CSS is like the looks of the website, and HTML5 is the backbones, the actual skeletal structure of the website. JavaScript is what makes, when you click a button, makes a box appear, or when you click something else, makes something move on the website. It's the actual like logic of the website, the magic, you could say. And the last part is PHP, which is basically what's run on the web server. Now, it's important when we're talking about websites here that we differentiate between what is a client and what is a server. So the client would be a web browser. That's what you're looking at when you're going to a website. You're looking at the website on your computer through Chrome, Internet Explorer, Firefox, Safari, something like that. That is the client, i.e. you. You are looking at something, and JavaScript is like happening in your browser, and PHP is happening on the server that's presenting you the website. So that's the difference between these two. So, to HTML. This here is a simple HTML website. If I were to put this in a web browser, it would read "Hello World" on the screen. And again, I talked about being a markup language. So basically, what this says that everything between this HTML tag, the one that's up there and the one that's down here, this is the website. What's happening in here is the website. What's in the head, i.e. the header of the website, is, for example, the title. What's going to read on the top of your web browser when somebody visits your website. In this case, it's going to read "Hello World." And in the body is the screen, the actual website that you view. So when you look at a website, everything that's below the back and forward button and above the icons at the bottom, that's your body. And inside these tags, you put all the graphics, the text, everything that the users see when they visit your website. In this case, I just put a header that says "Hello World." And that's pretty much it. This is probably one of the first things you would do if you started writing HTML. If you want to learn how to write HTML, you don't need to take a course in the university. I would recommend getting a book or going to a website called w3schools.com. That's the World Wide Web Consortium, and they actually have really good documentation for people who want to begin doing any sort of web programming. And HTML, I would recommend to you guys as your first glimpse into some form of development, because even though it's not an actual programming language, it still gets you going in the right mindset of how to take it forward to the next step, start learning about something else more advanced. The cascading style sheets I was telling you about, CSS, that's what the people in the industry are talking about. So you design something in HTML, that's where you define all the text, all the boxes, everything like that. But a standard HTML website won't have any look. It will just look like a bunch of text put together, scrambled. That's why you need CSS. Because with CSS you can connect a look with a certain element of a website. If I go back here to the HTML structure, you'll notice that there's an ID tag in this header that says "Hello World." So what this says is that this element here is given an ID called text. Now, what does this mean? I've just created a website that says "Hello World," and I want to make it look different. I don't want to have the white background with black text that says "Hello World." So what this means is I can use CSS and say, I want the text to be yellow, and I want the font size to be 14. So what you've just done when you've connected these two is that you've made your website have yellow text and font size 14 on the text that you printed on the screen. So with this little amount of code, you can make your website look differently. And again, this is just the basics of what you can do with CSS. But it gives you the basic idea that CSS is the looks, HTML5, HTML, that's just the backbone. Like a skeleton without skin. And JavaScript. Well, like I said, It's the functionality, what makes the page come alive. And here I've used a very disturbing and irritating example. The pop-up screen that everybody hates. When you go to a website and you get a pop-up, you usually get annoyed. But what this script, JavaScript, would do, if we were to put it in our Hello World website, it would pop up a small box saying Hello World to you. So then you would have to press OK and it will disappear. But anyway, this is again the JavaScript part of the website. So if we go back to the beginning, if you were to transplant the JavaScript into the header part of the website, you could make, every time a visitor comes there, it would pop up a box on the screen that says Hello World, and if you click the box, close the box, you will see the yellow text with another Hello World message in it. This is basically web development extremely simplified. Why I wanted to show you this is so that you get a basic glimpse of what this stuff is. We won't be able to go through coding in one evening. This is something that's going to take quite some time on your own, and you need to get the books and the resources to learn this stuff. And the most powerful tool you will have is the internet. All the answers are out there. The typical problem when you start developing is that you don't know the questions. That's why you need the books. And it doesn't matter if it's a digital book or a printed book, but you need to know how to ask the right questions. And there's loads of forums out there, and there's more help than there are people asking questions sometimes, it feels like. Yeah. If anybody wants to have any tips on what books to buy, what web resources to answer, then just come and ask me afterwards, and we can go through the ones that I know and I've used myself. The second part is the mobile apps part. Now this is the thing that everybody seems to be looking at the moment. This is pretty much the golden goose of the moment. Everybody wants to have an app. It doesn't matter what kind of startup or company that it's the new website. Everybody wants an app. And the most demanded programmers at the moment, I think, are app developers. So one of the biggest mistakes that people who are not programmers tend to do is to think that the websites and the mobile apps, they got to be the same. I mean, they're visual, have buttons and stuff, can't be that hard. Well, that's not true. It couldn't be further from the truth. I mean, mobile apps with the inclusion of touch technology, when we used to have the phones where you just had buttons, you press something, and something happened when you pressed the right button. That was pretty much an integrated or an embedded system, as we would call it in the programming world. The new smartphones, the touchscreen ones, they're like computers. They have real-time operating systems running there. Every touch you put on the screen will actually result in an action as it would in any normal operating system, as Windows, Mac OS X. So there's a lot more stuff going on there. The biggest difference is that when you press something now, if you have to wait more than half a second for something to happen on a screen, then you get annoyed. I press an icon in an app and it doesn't do anything. It just app freezes. Shit Apple, uninstall it. That's something that leads to the app developers needing to have really good programming skills. They need to be able to write really effective programs that are able to run very smoothly. There can be no user lag. I mean, I use Facebook. I got the latest app downloaded a couple of weeks ago. It's extremely slow. I get really irritated when I use it, and I don't want to use it anymore. And that's just an example of how frustrating it is. I mean, I use Facebook on the desktop every day, and there's no problem with using it there. I use it through the web browser. I mean, it's a website. How can it be so difficult to make it happen in an app? Well, there's again the question of resources. Like I said, the mobile phones today are like small operating systems running on the device the size of your hand, compared to this laptop or a big computer. The only difference is that the phone has a lot less resources available to it. the actual power of the device is much smaller compared to a laptop. So the applications that run on it need to be very, very effective. They need to be very well programmed, so to say. And the more bad programming you put into an app, the more slow it will become, and you will lose users. That's why apps are not trivial, and requires a lot of good UI design and good developers. Currently there are a multitude of operating systems for mobile phones. Android, iOS, Windows Phone 7, Symbian. There's even more. I just picked a few of the big ones. Again, as I said earlier with the whole programming languages, why are there more than one operating system? Again, it's a decision that the manufacturers have made, the operating system makers have made, and they just decided that, hey, we think we could do it better than these guys. We want to make our own system. So that's why we have this mess. If you want a developer to make you an iOS app, that does not mean that that same developer can make as a good Android, Windows Phone 7, and Symbian app for you. Now, when you think about that, that's quite a big problem. You can have one web developer and he can make a website that works in all the browsers. But you cannot have one app developer make everything work on all devices with the same level of quality. Now, from a company point of view, that's a big problem. If you have to have 5 developers compared to 1, you've just increased your cost, and your projects just grew by a lot of money. And so this is like another big important aspect of the mobile phone development process. One more thing about this OS world is that a lot of phones have different capabilities. So say, for example, Android is good at one thing, iOS is good at another thing. This means that your app, for example, if you're designing a website, you would have almost the same functionality throughout your app. Well, whereas the OS world would say that, hey, in Windows Phone 7, we don't like bright colors or gradients or whatever. We want you to have the app look like this. And then you need to make it look like that on iOS and like that on Android. So what you then said is that not only can I not use the same programmer to create the same app for these devices, I also need to have different UX designers create the look and feel and functionality of the app. So you've added another layer of complexity to the project. Now, as I said earlier, the fast and responsive UIs are everything when it comes to mobile apps. And good UI design means that apps get loved by the users, and the flow and everything, that's like the key thing. An ugly app will lose developers, a bad flowing app will also lose users. And it's really, really good that the UI and the code blend together in harmony, so to say. And this is not something that happens every day. There's the reason why you see certain apps climb to the top. And for example, Instagram is a camera application that you can take pictures with and share with your friends. These kind of apps have typically very beautiful UI design and try to add like things that are really easy to do. Typically only requires your thumb to operate the application. And note to self, you won't learn how to make an app in 1 week. Like I said again, it's going to take a lot of time if you're starting from scratch. You're going to have to learn how to do the basics before you can take off the training wheels and start making a real app. If you want to play around with making an app, there's a service called App Inventor, which pretty much allows anybody to drag and drop certain things into place and just create your own basic app. Again, that's not really programming, that's more dragging and dropping, but still, you can make apps easy if you want to. Also, I like animated GIFs. So finally about the stuff, 3 parts I talked about, the embedded systems. These are like the old school devices. When it comes to programming, you're talking about the old school MP3 players, not the iPods. You know, the ones where you would press play, like physical buttons, press play, pause, that kind of stuff. DVD players that you would have at home, like using the remote control to operate, and household electronics, like the refrigerators, mixers, whatever, like stuff that you have digital buttons on and stuff. So this again goes back to the low-level programming I was talking about in the beginning, where you have a almost binary code, really difficult code to write, because you have a device that's stupidly simple and have to do something that's you can't make a mistake with. You can't have a heart monitor that like stops working in the middle of the heart monitoring process. That's not a good thing, not a good feature. So this is the kind of stuff that most programmers don't want to do, because typically somebody's life or food or whatever is dependent on that everything runs as it's supposed to. And yeah, so this is the hardcore part of programming, so to say. And usually you would have no touch interface, you would have buttons, physical buttons on the device that you press and something happens. And to summarize here, like the low-level programming is usually tiers, and when you mix electronics, i.e. socket power, high power, whatever you might be dealing with, then that's even more pain. I mean, yeah, this is nothing I recommend for the guys who wanted to get started with programming, to get going with. And to summarize this part before I put you all to sleep, is there's many ways to start coding. You guys, I would recommend, if you want to really get going, is to use HTML. Use JavaScript, use Python, which is another great language to get going with. Find out from a buddy who knows how to program. Ask me, ask anybody here that programs in the farm, where can I get these books? What's a good resource to start reading if I want to get going with programming? And last part, yeah, that's self-explanatory. You just need to do this stuff in order to learn it. You can't read a book and then go say, oh, well, I read Sam's Learn How to Write C++ in 31 days, give me a job. That's not going to work, because even though you can read it, doesn't mean you can do it in this case. And that's one of the fundamental differences when it comes to reading the manual and actually being able to do something with it. So, again, if you want to ask for book tips, ways to get started with coding, ask away. Does anybody have any questions now? With regards to coding, with regards to any of my confusing examples? Yeah?
Yes. Okay. I want to ask you, let's say it's very hard to find a good programmer, right?
Yeah.
So let's say I'm an entrepreneur. I want to find someone who is good at something, but you know there are many kinds of programmer, and you don't know the level of these people. Is that a way or a trick to know that this person can do it well?
So the question was, how do I find a good programmer that's right for the task, and how do I know that he actually knows what he's claiming to know? So this is not an easy question, and the reason being that big companies like Google, Facebook, they all look for coders, and they have really extensive hiring processes where you either go there or they interview you live, and you have to write code where actual experts would be monitoring the way you write your code, how you look for information, how you solve bugs and that stuff. When you have a small company, or like you're going to start a company, the only tip I can give you is that ask a friend of the guy. If you have a buddy who knows programming, you know he's decent what he does, write you up a few questions. Bring him along with the interview, even though he's not going to work with your company. Have him sit down with the guy who's supposed to know the programming, and ask your friend to write down some questions for you and have them answer them. And also, another really great thing that I recommend anybody who's doing a program, asking for a programmer to do, is ask him to do something for you. Make him a mini project. Make me a calculator that looks nice. That's something, again, a CV. I can put anything on a CV. I mean, on LinkedIn you can put anything. It doesn't verify anything that I put there. So what you want to do is have somebody show you what they can actually do. And that's the only thing you can do that, is to ask them to do something for you. A very simple application, or something that has to do with what you want him to do. So that's a really good way to get to know a guy. Yeah.
You said earlier that it will take like 10,000 hours to
I've said this at many parties and after many beers that I could teach anybody how to make a website in under a week. With regards to like patients in vegetative states and that kind of stuff, but like if you really want to learn how to make a website, for example, then that's something I can teach you. If you want to learn how to make a mobile app, there's no shortcuts there. You have to learn a good programming language, and you have to learn some fundamentals of operating systems that simply doesn't come for free. I wish we had the Matrix devices, just plug in and learn, but it doesn't work like that. And even though there are some really kick-ass literature out there that will help you speed up the process, avoid some of the pitfalls along the way, it's still a long journey. I mean, and the 10,000 hours, again, it's not like you have to sit down inside a mountain 10,000 hours and read books and code. It's more like the journey that I want to say, that you have to sit down, you have to start doing projects, you have to go to code meetups, hackathons, this kind of stuff where you get together with people that are better than you. You want to always associate yourself when you're starting to learn code with people who you know that are better than you. If you just sit in a room with guys who are just starting out to code, you probably won't learn that much. But if you go to events where people are making really cool projects and ask them, hey, how are you doing this? Can you show me how you did this? That's the way you can advance your skills, by meeting people that are better than you. Any more questions?
I would actually like to comment on something
Yeah.
that you've said. Because I know for a fact that 2 years ago I met a guy who was 19 years old. He was a Swede. That's plus side, by the way. He wanted to learn to code. And he knew absolutely nothing. He just came out of college in Sweden, I think it was somewhere in Stockholm, if I recall correctly. And he said that, but I'm going to learn to code. And everyone was like, okay, well, it's going to take you 8 years, because that's roughly how the industry perceives things. But he started learning, and he didn't read any books. In fact, he hated reading books. That's one of the reasons he dropped out of school early on and just wanted to just go crazy at it. Instead, he found really good communities, like GitHub. It's a really good community, much perceived to what you were looking for, good coders. There's really good community and people really doing each other favors. And he was starting to look at tutorials, because there's lots of tutorials, just like he mentioned, there's a billion amount of tutorials on web, especially. The bridge between mobile, that's what you brought up. You can make pretty okay service-based applications for mobile via web services. So you don't have to go into machine languages like he has put in there. And I think that one thing he did in 2 years, he did because he was inspired to do so. And he was inspired because he had a great idea and a great concept, and he lived by that great idea. And if you have a great idea, use that inspiration and do things, and there's plenty of resources.
That's the key thing that you said there, is the motivation part. I mean, again, like 10,000 hours, that's like I said, a journey, learning how to program over years. There's also like the human factor here. Certain people are more have an easier way of absorbing this kind of stuff. If you're just like a mathematically talented person, you might grasp certain concepts easier. Or if you're just a visual guy, you might grasp some things easier with regards to like looking at design documentation and just looking at the visual ways a program is built. Of course there's going to be variation in how fast you learn how to program, but like the key thing here is like the passion to do something. Like you said, that you want to do something, then that's the first step there, to get the passion, get the books or get the online forums, ask the questions, get the tutorials, and just start writing code. And like you don't have to read the book from cover to cover and then start typing. It should be like more of a learn as you go process. Anything else? In case not, then we'll have a snack break, beer break, water break, toilet break, all kinds of breaks. And then we'll have a more open discussion about being a programmer, being an entrepreneur, and we'll discuss some of the stuff that, hey, how do you take your lead coding skills to a actual company. Yeah, but enjoy some beer.